Welcome back, focused learners. Today we're diving into another explainer. And, we're exploring something that honestly feels like modern magic, but it's actually just pure, elegant science. We're unpacking the architecture of silence, how noise-canceling headphones actually work. If you've ever put on a pair of these things, you know exactly the feeling I'm talking about, right? It's that immediate, almost shocking sense of relief. A sudden quiet that washes over you, kind of like stepping right into a soundproof vault. But how in the world does this actually happen? Well, we're going to break down the mechanics step by step and visualize this invisible world of sound. Okay, let's dive into this. So picture this. You're crammed into a super busy subway car. The screeching of the metal tracks is absolutely deafening. People are shouting over each other, or, maybe you're strapped into an airplane cabin, just surrounded by that relentless, droning roar of the jet engines. It's grating. It's exhausting. It's basically the chaotic soundtrack of modern commuting. But then, you reach up, you flip a tiny little switch on the side of your headphones, and instantly, absolute silence. The roar just vanishes. The screeching melts away. You're suddenly left in this blissful, isolated bubble of peace. It's a completely shocking contrast, isn't it? Which naturally leads us to a pretty fascinating question. Let's just really pause and think about this for a second. How can a piece of plastic and metal physically erase sound? Think about it. Sound isn't just some abstract idea, right? It's physical energy. It's literally traveling through the air and hitting our eardrums. So how on earth can wearing a device that produces sound actually result in total silence? It genuinely feels like an impossible magic trick, like an illusion that's just flat out defying the laws of reality. Well, spoiler alert, the answer isn't magic at all. The secret lies in a fascinating physics principle. Now, what's really interesting about this slide is the shift from the subjective feeling of quiet to the objective reality of wave physics. Sound, at its absolute core, is just invisible pressure waves traveling through a medium, usually the air around us. So to erase that sound, we actually have to physically manipulate those waves. And that brings us to a really cool concept called destructive interference. This is simply a process where one wave directly cancels out another. Remember, sound is a physical wave. It has peaks, where the air pressure is high, and troughs, where the air pressure is low. Because it has this actual physical, mathematical structure, it means it can be systematically counteracted. If you can understand the exact shape of the wave that's about to hit your ear, you can theoretically build a custom weapon against it. To really grasp destructive interference, though, we need to visualize it. So let's use a water wave analogy, and this brilliantly illustrates the concept. Imagine you're standing by a perfectly calm pool of water. If you drop a stone in, ripples radiate outward. These are exactly like sound waves, just visible. They have crests that rise above the surface and troughs that dip right below it. Now imagine one of those water waves with a noticeable dip, a trough, moving right towards you. Now imagine we send a second wave to meet it, but this second wave is timed absolutely perfectly so that its peak, its highest point, matches exactly with the dip of that first wave. The peak of the second wave essentially acts as a filler, perfectly neutralizing the dip of the original wave. The high pressure and the low pressure, they just add together to equal exactly zero. The result? A completely flat, undisturbed surface. Those two waves have literally destroyed each other. Let's move to NSC and see how this builds into the real-world technology we use every day. We're taking that water wave analogy and applying it directly to invisible sound waves. That screeching subway or that roaring jet engine, those are just chaotic pressure waves crashing against your eardrums. If we can generate an opposing sound wave, one that matches every single peak with a trough and every trough with a peak, we can flatten out the air pressure before it ever even reaches your ear. We're creating an acoustic flat surface. And that flat surface is exactly what our brains perceive as pure silence. So, how do your headphones actually pull off this crazy trick in real time? Well, they use what I like to call the magic process, and it operates in 3 super simple steps. 1, listen. 2, invert. 3, play. It is an incredibly tight, ultra-fast mechanical sequence that executes the ultimate illusion of erasing sound. Your headphones aren't just passive earmuffs, they're actually active, highly sophisticated audio processing computers operating in milliseconds. Let's break each of these steps down. Let's start with step 1. Microphones listen to the external noise. Built right into the outside casing of your headphones are these tiny, highly sensitive microphones. Their entire job is to constantly eavesdrop on the chaotic environment around you. Whether it's the loud subway, the airplane cabin, or even just the annoying hum of an office air conditioner, these mics are capturing the exact shape and frequency of the offending sound waves as they approach your head. They're basically gathering all the intelligence needed for a counterattack. Next, we have step 2, the internal chip inverts the sound wave. This right here is the absolute brain of the operation. The microphones send all that acoustic data they just collected to a highly specialized microchip inside the headphones. This chip works unbelievably fast to analyze the incoming noise wave, and then, using some quick math, it flips it completely upside down. It creates an exact mirror image negative of the noise. If the subway noise goes up, the chip calculates an identical wave that goes down. It's manufacturing the exact filling for the dip that we talked about in our water analogy.
And finally, step 3. The speaker plays anti-noise to cancel it out. The internal speakers of your headphones, the exact same ones playing your favorite music or this very explainer, simultaneously broadcast this newly created inverted sound wave directly into your ear canal. So the crucial point is that this anti-noise collides with the original external noise right in that tiny little space between the headphone speaker and your eardrum. They undergo that destructive interference we defined earlier. The waves perfectly cancel each other out, leaving you with nothing but that pristine, engineered silence.
It's honestly an astonishing feat of engineering, isn't it? Turning sound against itself just to create quiet. But it also leaves us with a pretty fascinating thought to ponder as we wrap things up today. Would you rather have perfect silence everywhere you go, or would you keep some background noise to feel connected to the world? It's a genuine philosophical question about how we choose to interact with our environment using everyday audio technology. Do we want to isolate ourselves entirely, or is there a certain comfort in this subtle hum of humanity? Think about that the next time you flip that switch. Thank you so much for joining me for this explainer, focused learners. Keep studying, and until next time, stay curious.